Hello and welcome to the channel. In this video we're going to be talking about non-numeric data types. In previous videos we talked about, the numeric data types when we're storing non-decimal values like a non-decimal number, integers, and we talked about storing decimal values, and you might know the int, the short, the byte, the long, the double, the float. We also have values that, are non-numeric, like when we type in, a character, single character, or we got words or letters that we would like to put in, or sentences completely. And we want to store those with data types too, or that data as well, sorry. Because, somebody's got a name, that's typically a series of letters or characters that are put together to make a name or a word. So when we're dealing with like characters, we're going to deal with just single characters or symbols at this point. What we do is we type char. Now char is for storing a single character. Now we'll give it a name. I'll just name it single underscore character. Right? And we'll just make that equal to, we'll just say the letter capital A, uppercase A. In order to make sure that it is an actual character, only a single instance of a letter or a symbol, you have to use these single quotes. Now the double quotes, if you're going to try with the double quotes, it actually will not work at all, because you'll get an error. If we just hover here, incompatible type string cannot be converted to a char. So this double quotes is actually to represent a string, and we'll talk about a string in the next video or in other videos. For now, we're just going to talk about a character, and in technical, like a string is just characters that are strung together in essence. They're, a word is technically, you take a couple characters and you put them beside each other and you form a word. So that's kind of what a string is. If we string a bunch of characters together, we'll get a word. So we can do that now. We'll just take, we'll name this one H, just to make it represent the letter H. I'll show you what's going to go on here with this, and we'll come down, we'll just go and we'll make a word. We'll just say hello. We'll make this one E, and we're just naming it the variable just to represent that it's an E being stored there. And we'll keep going down. We'll make an L, we'll make an O. And we'll just, take these little letters that we're working with to create the word hello. We can't name that the same. So we have this here, and we'll just go system.out.print. Print. And what we want to do is we want to take the values, these values here, and we want to print them out to try to form a word. So you might say, okay, we take the H, and this is not an actual, a letter. It's actually this variable's name that we named it, the letters stored inside of it. So, technically we could just go, H, like that. And, we could type these all together, H, and an E, and an L. We don't have to actually store them to the values like this. But just for educational purposes, we'll just name them, and we'll call them by the variables. And we'll go hello. We'll type out hello here. And I'll show you. And we'll actually do it in another way here. At the top, we'll just go up here and we'll say print line. At this point, we can just print line again. And now what we're going to do here is we'll actually just print out those characters like we said we were going to, before. So it's technically like going just like this. And I want to kind of show you what's going to happen here. And we'll go hello. Very basic. It's not something that you're technically going to do. You're not going to form words like this or anything, but just to kind of show you what's going on here. So if we run this code, we'll see something happen. If you look, we're getting these number values, but we're kind of working here with characters, right? We don't, in essence, we don't believe that like we wanted to spell out hello by, putting these values together. And before we used this, it was, adding string values together, and it kind of put, sentences together, or it put a word together for us down there. What's actually happening in here is that each one of these characters is representative. It has a number and a value based on the binary version of it. Like if we were to break this down into a binary number, it had to represent it so that the computer can understand it, right? And there's a Unicode encoding system that is used in order to represent letters in computer form. I'll kind of give you a little bit of a hint of what's going on here. We'll say int character is equal to, and we'll just make it the letter H. Okay, it's kind of weird, right? Before we were doing data types, and we were always putting, a non-decimal place would be for an integer, so we would always, 65. So why are we able to put this character into this, inside of this data type? And I'll show you what's going on here so that you can understand it. And we'll run that. And now there's an octal number or a base 10 number that's being represented here. We get 104. So the letter H, if we know this is a third printout and it said 104, we can actually type up here 104. And that will actually be the represented number in an integer form to the letter H. And it won't give us any errors or any problems with that. It's absolutely perfectly fine to do. If we do it with the E, we'll save this file and run it, and we'll see that we actually get, the same. When we go to this character now, we get 101, we get E. So now down here, in order to make this actually print out a string or like a word, what we got to do is we got to kind of make it know that it's concatenating to a string. So we just put these double quotes here at the very beginning, and it will, now what it does is actually acts as if it was appending these to a string rather than taking their integer values and adding them up. So now we've converted these into concatenation, whereas before they were actually doing straight addition on these values. We've now taken this and concatenated it to a string. So now we're actually appending each of these letters into a string form. And if you notice up here, look, we got 104 and 101. You would think, okay, well, this is just going to give us a string and then print out 101 or 104, then 101, and then maybe it would go into LLO. So you think, okay, we're going to get 104, 101, LLO. But if we run this now, you're going to see, and here we go, you're going to see it actually prints out the full word hello for us. That's because, in computers, computers are really only big calculators and using numbers to represent different values. So we can kind of use this to represent the value for us. And there's a whole bunch of, these are very basic, and you're not really going to probably use, the character form here. It's more going to be like, so if we went down and said char, we'll just call it symbol. We'll make it equal to, we'll just go, I gotta make it single quotes only. And we'll make this equal to a Unicode value. And again, these all have Unicode values that are available to them too. And if we said, we go \u, and if you type 0041, now the alphabet starts with a capital at 41. So if we come down here, and I'm going to type this out, just say, it'll just kind of give us a little bit of the int result. We'll just do that so that we kind of know that it is a integer result to the character. And then here we'll go, this is kind of weird too, we'll show you what's going on here, but if we go to, we'll just say, this is hello, this is just fine, we'll leave that as that, and this will give us like the full number value. we don't even need it. Truthfully, here, we'll just take that out. So we'll print out hello, then we'll print out the number value, and then we'll print out, let's get that symbol printed out. We'll just stick a system out here, and we'll say the symbol result, right? And we'll type the symbol down in here. I hope you're following along. It's not, you don't really need to do this or anything. It's just kind of to show you what's going on. So in this form here, this is the Unicode form, and you can look up, there's tables all over. The symbol result for the Unicode at 41 is actually the capital letter A, or the uppercase A. And that's where it starts at 41. And if you were to go through, you know, 42 would be B, 43 C, and so on, all the way down. You know, once you get to say 65, we'll run this here. We'll hit it. Oh, now we get an E, a lowercase. So now, you know, if we go 60, we hit run. Oh, we get this like little comma, or not a comma, what would that be? A tilde. I'm not even sure what that actually would be. Like a quote, air quote, or quotes, single quote. It's up beside the one on a shift. Not really a single, but now there. So 61 is our lowercase letters. So at 41, all the way up until, you know, 25 letters in our alphabet. So that would be all your uppercase, and then from 61 added on, you'll get all the lowercase values. And then there is other values that are stuck inside here, which, you know, if you take 98, and again, I'm just kind of poking away at letters at this point here. I'm not really referring to a chart, just to show you that there is other, you know, symbols. This one doesn't have actually anything signed to it. If we get up a little higher, say, you know, we'll go 255. Have to actually go here, 255. We should run that one. I'm trying to just get a value that will give you a symbol, just so you can kind of see. Here we go. Little awkward symbols that are available. There is a whole entire chart that will show you this, and we are in programming. We can truthfully print out every single value that's available to us. And it's kind of important to know, like, these numbers aren't really reference to these numbers here. So if we typed in here, you know, 104, we hit enter, you're not actually running and getting the character of H at this point. It's represented in its own Unicode, but so you get this like A with this weird little down like bend at the bottom of it. So again, there's a whole bunch of different ones. Like this goes up pretty high. There's actually quite a few when it comes down to the different letters that are available. And the same thing goes with the integer values. See, this symbol's actually not really assigned to anything, so it's kind of what you're going to get when it's not necessarily assigned to anything. So I'm kind of like stabbing away at numbers in a way. So if we went say, you know, 970 up here, and we run that code, we'll see that the H, this technically shouldn't be H anymore. It won't say hello anymore. You see, we get, oh, actually didn't do anything. Well, that's different. It didn't actually, oh, because we're actually printing out this, so that's why. Sorry, I erased the wrong one. It came down to, we're actually only doing literal characters. That's my bad. So now the H should actually be representative of this letter here, or this number here. The rest will say, you know, ELLO, but this one's going to be very off. You see this kind of weird symbol. There's a bunch of them. There's so many of them in there. If you need to do like subscripting or superscripting, where your letters, you need to get an exponent, or you got to put the letter below your other letter to kind of represent mathematical equations and stuff like that. There is like a ton of really useful symbols here. So do refer to the Unicode chart, look that up for yourself, and just know that it's not technically just defined as a, you know, the only things that are on your keyboard. This is going to be how you find and represent values that aren't available to the keyboard. There's Chinese values, there's, you know, there's different languages, different dialects have different ways of actually producing values, you know. So like if you wanted to get, say, Chinese letters, they're way up in the like 600, there we go, 68, we'll go 6B 22, that's actually a value. And when we are doing this, like, this is a hexadecimal version of it, so we'll just call this one symbols. And technically what that means is hexadecimal is like representing numbers using like base 16, and it goes from 000, and then when you're representing any numbers higher than 10, it goes, A would be, you know, your 10, B is 11, C is 12, D is 13, E is 14, and F is like a 15. And that's kind of what a hexadecimal is. So we can go up right up to FFF. I don't think there's actually a value stored in FFF. We'll just append it to here just to kind of show you whatever be. There's values that are up that far, but we'll just run that and see what we get. And this symbol here is like a Chinese symbol. I think if we get, you know, up in those values, here's a cool little Chinese symbol here. Again, you can just play around with it too. You don't have to, like, oh, there's so many of them. I think there's like a million of them or more, like maybe a little over a million, 100,000 over or something like that. Here's another, you know, Chinese value that's represented here. So there's a whole bunch of different representations or different symbols that we have access to, and we can print out, and we probably will print out a chart. At one point we'll make another little, you know, program that will print out the whole ASCII character chart and just kind of have it available to us. Kind of a weird Chinese one here too again. So yeah, just know that that's, you know, single characters and storing them. And if you need to refer and bring symbols into your, you know, into your program at all, then that's one way that you can do it. You can, you know, we can type in Chinese letter. I don't know what letter it is, to tell you the truth. Like, that's not, I don't really know. We'll just type symbol. Right, Chinese letter, and you can put that in there, or you can actually just take this right out of here and stick it right there. That'll be fine too. So maybe on the fly you want to just, you know, put in a symbol that we need to, you know, show a symbol, or again, like maybe a degree, you know, you got like 78 degrees, you can actually find that little symbol that would be for the degree, and you can put it beside your number. I don't really know the degree symbol at the moment. I can stab away forever at it, but for time's sake, I'll just show you that. And that's how we would store and work with non-numeric data types, just a single character only, and symbols and different things that aren't available to us on the keyboard. So that's it for this video. I hope you enjoyed, and if you liked the video, give it a thumbs up. If you'd like to see more videos like this, just subscribe to the channel and check out the rest of it. If you have any comments or questions, or if you have any like ideas for future videos or topics you'd like me to cover, just leave it in the comment section below, and we'll try to get, you know, around to those suggestions. And just thank you very much for watching, and we'll catch you in the next video.